When upgrading your electrical service, proper grounding and bonding are critical for safety. Firstly, let's discuss bonding the neutral to the ground. Yes, the neutral conductor in both service boxes, that is, the main service and the garage service, should be bonded to the grounding system. This involves connecting the neutral bus bar in each box to the grounding electrode conductor, or GEC, usually using a number 6 American wire gauge, or OG, bare copper wire. This connection ensures that any fault current can safely return to the source. Secondly, consider the need for an additional ground rod at the garage service box. Yes, it is recommended to install an additional ground rod at the garage service box. The reason for this is that the grounding electrode conductor, or GEC, from the main service box may not provide adequate grounding for the garage due to its distance. The ground rod should be at least 8 feet long and driven into the ground in accordance with local electrical codes. The grounding electrode conductor, or GEC, from the garage service box should be connected to this ground rod using a number 6 American wire gauge, or bare copper wire. This provides a local grounding point, enhancing safety. Here's some additional information to keep in mind. Ensure the grounding electrode conductor, or GEC, from the main service box is properly sized for the new 200 amp service. Refer to the National Electrical Code, or NEC, for the correct wire size. The National Electrical Code, or NEC, Table 250.66 provides guidance on sizing the grounding electrode conductor, or GEC, based on the size of the service entrance conductors. Use copper or aluminum conductors for the grounding electrode conductor, or GEC, and all other grounding connections. Copper is generally preferred due to its excellent conductivity and resistance to corrosion. All plumbing, gas lines, and ductwork within the garage should be properly bonded to the grounding system. This helps to minimize the risk of electrical shock by ensuring that all metal parts are at the same potential. The National Electrical Code, or NEC, Section 250.104 outlines the requirements for bonding metal piping systems and exposed structural metal. While this information provides a general overview, it is crucial to have a qualified electrician perform all electrical work and obtain all necessary permits. Electrical work can be dangerous, and a professional electrician will ensure that the installation meets all applicable codes and standards. Let's delve deeper into the technical aspects of grounding and bonding. Grounding refers to connecting the electrical system to the earth. This provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or a fuse and energizing the circuit. Bonding, on the other hand, involves connecting all metal parts of the electrical system together to create an equipotential plane. This minimizes the voltage difference between different metal parts, reducing the risk of electrical shock. The grounding electrode system typically consists of one or more ground rods, ground plates, or underground metallic water pipes. The grounding electrode conductor, or GEC, connects the grounding electrode to the service equipment. The size of the grounding electrode conductor, or GEC, is determined by the size of the service entrance conductors as specified in the National Electrical Code, or NEC. The neutral conductor is the conductor that carries the return current from the load back to the source. In a grounded system, the neutral conductor is bonded to the grounding electrode conductor, or GEC, at the service equipment. This creates a single point where the neutral and ground are connected. The equipment grounding conductor, or EG, is the conductor that connects the metal parts of the electrical equipment to the grounding system. The equipment grounding conductor, or EG, provides a low impedance path for fault current to flow back to the source, tripping a circuit breaker or fuse. The equipment grounding conductor, or EG, can be a wire, a conduit, or other approved raceway. The size of the equipment grounding conductor, or EG, is determined by the size of the circuit conductors, as specified in the National Electrical Code, or NEC. When installing a subpanel, such as in a garage, it is important to properly ground and bond the subpanel. The neutral conductor in the subpanel should not be bonded to the subpanel enclosure. The neutral and ground conductors should be kept separate in the subpanel. A separate equipment grounding conductor, or EG, should be run from the main service panel to the subpanel. This ensures that there is a dedicated grounding path for the subpanel. The size of the equipment grounding conductor, or EG should be determined by the size of the circuit conductors feeding the subpanel, as specified in the National Electrical Code, or NEC. When installing a ground rod, it is important to drive it deep enough into the ground to reach moist soil. The top of the ground rod should be at least 8 feet below grade. The ground rod should be made of copper or copper-clad steel. The connection between the grounding electrode conductor, or GEC, and the ground rod should be made with a listed connector. When bonding metal piping systems, it is important to use bonding jumpers that are sized according to the National Electrical Code, or NEC. The bonding jumper should be installed in a way that ensures a continuous electrical connection. When bonding gas lines, it is important to avoid creating a spark hazard. The bonding jumper should be installed in a location where there is no risk of igniting flammable materials. When working with electrical systems, it is important to always follow safe work practices. Always to energize the circuit before working on it. Use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Work in a well-lit and ventilated area. If you are not comfortable working with electrical systems, hire a qualified electrician. The National Electrical Code, or NEC, is a set of standards for the safe installation of electrical wiring and equipment. The National Electrical Code, or NEC, is updated every 3 years. It is important to stay up to date on the latest edition of the National Electrical Code, or NEC, to ensure that your electrical installations are safe and code compliant. The National Fire Protection Association, or NFPA, publishes the National Electrical Code, or NEC. The National Electrical Code, or NEC, is adopted by most states and local jurisdictions. When installing a 200 amp service, it is important to use the correct size conductors. The size of the service entrance conductors is determined by the calculated load of the dwelling unit. The calculated load is based on the square footage of the dwelling unit, as well as the number and type of appliances. The National Electrical Code, or NEC, provides guidelines for calculating the load of a dwelling unit. When installing a 60 amp branch circuit to a garage, it is important to use the correct size conductors and overcurrent protection. The size of the conductors is determined by the ampacity of the circuit. The overcurrent protection should be sized to protect the conductors from overload. The National Electrical Code, or NEC, provides guidelines for sizing conductors and overcurrent protection. When running electrical wiring underground, it is important to use the correct type of cable. Underground feeder, or UF cable, is a type of cable that is designed for direct burial. Underground feeder, or UF cable, is moisture resistant and can withstand the rigors of being buried underground. The National Electrical Code, or NEC, specifies the requirements for installing underground wiring. When installing electrical equipment in a garage, it is important to protect it from physical damage. Electrical equipment should be installed in a location where it is not likely to be damaged by vehicles or other objects. The National Electrical Code, or NEC, provides guidelines for protecting electrical equipment from physical damage. When working with electrical systems, it is important to be aware of the potential hazards. Electrical shock is a serious hazard that can result in injury or death. Arc flash is another hazard that can occur when working with electrical equipment. Arc flash can cause severe burns and other injuries. It is important to take precautions to protect yourself from electrical shock and arc flash. Always to energize the circuit before working on it. Use appropriate personal protective equipment, or PPE, such as gloves and safety glasses. Work in a well-lit and ventilated area. If you are not comfortable working with electrical systems, hire a qualified electrician. Here's a summary of the key points. Firstly, bond the neutral conductor in both service boxes, main and garage, to the grounding system using a number 6 American wire gauge, or ALG, bare copper wire. Secondly, install an additional ground rod at the garage service box, at least 8 feet long, and connect it to the garage service box with a number 6 American wire gauge, or ALG, bare copper wire. Always refer to the National Electrical Code, or NEC, for specific requirements and consult with a qualified electrician to ensure safe and code-compliant installation. Remember to properly size the grounding electrode conductor, or GEC, for the 200 amp service. using copper or aluminum conductors for all grounding connections, and bond all plumbing, gas lines, and ductwork within the garage to the grounding system. Safety should always be the top priority when working with electrical systems. By following these guidelines and working with a qualified electrician, you can ensure safe and reliable electrical installation for your home and garage. In summary, the key to a safe and effective electrical system lies in proper grounding and bonding. This involves connecting the neutral to ground at the service equipment, providing a dedicated grounding path for subpoles, and ensuring that all metal parts are bonded together to create an equipotential plane. By following the guidelines of the National Electrical Code, or NEC, and working with a qualified electrician, you can protect yourself and your property from the hazards of electricity.